Now we move from measurement to evidence. It is a common mistake to think that asking good questions equals good evidence. In reality, the equality of our evidence depends entirely on where the data came from and who provided it. Before a single variable is measured, a psychologist faces a major decision regarding the source of their evidence, primary or secondary data. This choice isn't just about convenience. It fundamentally affects the control, validity, and feasibility of the entire study. You must have to balance cost speed against the need for very specific information. So, primary data is information you gather yourself, specifically for the purpose of your current study. Whether you're running an experiment, or sending out questionnaires, or conducting interviews, you're the one collecting the raw information. The strength is that it perfectly tailored to your research aim, and it is completely current. The weakness is that it often a massive undertaking. It is expensive, time consuming, and requires significant effort. Alternatively, we have secondary data. This data already exists, gathered by other researchers of a different purpose, which you will reanalyze them and use for your own needs. Think of a government statistics, sinus data, or meta-analysis. Strength. It often free or inexpensive, and you can access massive datasets in seconds. The weaknesses are that you are in the mercy of the original researcher. The data might be outdated or might not quite fit the specific niche you are investigating. Once we know the type of data we want, we have to find the people. This is the logic of sampling. The target population is the large group you are interested in. The sample is the smaller group you actually study. The goal is the representativeness. If your sample is true mini version of your target, then you can generalize your results back to that larger group with confidence. The most straightforward way to avoid bias is random sampling. In this method, every single person in the target population has an equal chance. It is like drawing names out of a hat. While it is excellent for minimizing researcher bias, there is still a small risk of ending with a freak sample that doesn't reflect the whole group purely by chance. Let's briefly evaluate random sampling. First, the strengths. Random sampling is unbiased because the researcher cannot choose participants to support their hypothesis. It is also fair, since every member of the population has an equal chance of being selected. However, there are weaknesses. It can be time consuming. There is no visual bias, meaning selected participants may decline to join, which can affect the representativeness. And finally, even with proper random sampling, chance can produce an unrepresentative sample, even if the sample size is small. To be even more precise, we use stratified sampling. This is a three-step process. First, we identify strata, subgroups like managers versus the clerks. Second, we calculate their proportions in the real world. If 50% of the population are clerks, then 50% of our sample must be clerks. Third, finally, we randomly select the required numbers within each subgroup. The main strength of stratified sampling is that it is highly representative. By dividing the population into key subgroups, such as gender, income level, or region, and sampling proportionally from each group, we ensure that all important segments are included. This reduces the risk of excluding minority groups. However, the weakness is that it is extremely time consuming. It requires detailed knowledge of population proportions and accurate classifications of individuals into strata. This makes it more complex and harder to execute than simple random sampling. With random sampling, the key feature is equal chance for everyone. It is best for minimizing researcher bias. However, the risk is that by chance, the sample may end up unrepresentative. With stratified sampling, the key feature is proportional. It is best when we want accurate representations of diverse groups. The trade-off is that more labor-intensive and complex to implement. So overall, this becomes a question of accuracy versus practicality. In the real world, psychologists often have to balance representativeness against practical constraints like money and time. Volunteer sampling is when participants select themselves, usually by responding to an ad. It's easy, but it carries a high risk of volunteer bias. Opportunity sampling is simply picking whoever is available at that time, like people walking past you in a mall. It is fast but rarely unrepresentative. Every sampling choice is a trade off between the ideal and the practical.